Welcome everyone, welcome back to another one of my PowerBox series of videos. Hope you're enjoying them so far. In this particular video we're going to be looking at flap deployment, and in particular we're going to be looking at also incorporating automatic elevator compensation. So, flap deployment. In a lot of cases people will set up flaps on a switch, fair enough, and they might delay the servo speed and they're happy with that, that's fine. In this video I'll show you how to do that in the core, but we're going to pull a few little tricks so we can automatically compensate with our elevator. So if you do deploy your flaps and you get some pitching up of the aircraft, we can put in a little bit of down elevator to compensate. Okay, so I wasn't sure how to progress with the video. I was going to make a video of the screen filling up most of the video and then have a little subset video with the servos, but I decided against that. So in this particular video I'll show the screen just continuously in the top right hand corner here in real time, and obviously on the left I've got my little test jig which I just knocked up this morning. We've got a couple of aileron servos which we won't need for this particular video. I've got two flap servos, so I've got a left and right flap servo, and these are just plugged into the third and fourth socket on my receiver. And then we have our two elevator servos. So I could have used just one elevator, but for further examples that I'll be probably showing on videos, I decided to actually use two elevator servos to mimic the elevator movement. So we have a separate left and right elevator servo, and these are plugged into sockets 5 and 6 respectively. As most PowerBox users are aware, the system basically allows you to use any servo, assign any servo to any socket. It's fairly free as assigning whatever flight service you want to any socket number, so to speak. Not to be confused with your channel numbers. Okay, so let's go into the functions menu just to have a look how I've set this particular model up. So you notice I've got ailerons here. So I've got ailerons, it's on stick D. I'm a mode 2 pilot, so stick D's over here, and you can see the aileron servos moving. So if I go full right aileron, we can see the right servo moving towards the top and the left aileron servo moving towards the bottom, just to indicate, you know, basic aileron travel. Again, we won't be needing it in this particular video. We've got our flaps. So at the moment I've just set them up to a switch, and I'll come back to this in a second. These are on sockets 3 and 4 of the receiver as labelled on my little plate here, metal plate. And same with the elevators. Obviously elevators are on stick C, and we're using sockets 5 and 6. And we've got the throttle, which I don't have a servo representative of the throttle, but that's just assigned to port number 7. And then you've got the rudder. Again, I haven't incorporated it on this particular test jig, but it'll come in handy later when I show you where we use flight modes, where we exclude some of these actual servos from being incorporated into the servo delay. Okie dokie. Flaps. At the moment I've assigned them to the switch. So if I move the switch, at the moment the switch is fully forward to indicate 0 flap deployment. So this will be your normal 0 degree flap position. I have exaggerated the travel, so I've got a full 90 degrees travel on these servos. So in the middle position we've got, say, our takeoff flap position or our mid flaps, and then you've got full flaps with the switch fully pulled towards me. So again, I've exaggerated the position to indicate the full flap travel. So generally when we set these up, a lot of pilots, what they would normally do is we'd set the switch to center, you would set your mid flap travel position, and then either side of that you can then set your endpoints, so you can set your 0 degree flap position and also your full landing flap position, for instance. And that's all I've done here, nothing special, fairly straightforward. But as you can see, the servos are moving just at their normal speed. And in a lot of instances we want to delay the flap deployment. We don't want them to operate at full speed. So what would you do? So one easy option is we can go into the function menu here and go into setup, and we go into the function curve. So not the servo curves, but the function curve. So if I highlight that, and we're now into the curve for the function. So I can adjust the throw or the steps in the curve, so I can make my own weird travel instead of it being linear. We're not interested in that in this particular example. However, if we scroll to the bottom of the screen, you'll notice there's this runtime value. And if we change this, we can actually slow the servos down. So we're slowing the function down. So basically any servos assigned to this particular function, in this particular example we've just got the 2 flap servos, will be slowed down by this value. So if I operate them now, you'll notice that they move slowly. Now I've only done it in one direction, so if I go back the other way, they should operate at full speed. There you go. Again, easy as. Now people will say, oh, that's it, that's all you need to do. Well, there's a problem with this setup insofar as this speed here pertains to a constant speed for the servo. So if the servo only has to travel a little bit, so for instance if we're deploying the flap say 10-15 degrees, the actual time elapsed between 0 and that 10 or 15 degrees will be a certain time. Now the servo will always travel at this 3-second indication. So if the servo has to travel more than that, it's going to travel at this constant speed. So if we have 2 settings for the flaps, it'll take a lot longer for the servo to travel a lot further. So for instance, watch this. So I'll go to the first switch position, which is mid flaps, and then I'll go back to 0, and then we'll go back to full flaps. And you look how long it takes between the mid position and the full flap position. Okay, so that was mid. I'll do that again. Now let's go to full throw. Now you notice it takes longer. So basically what this time here is setting is actually adjusting the actual speed of the servo, which is all very well. That's fine for, for certain applications. However, if we want to align it with automatic elevator compensation later on, it gets tricky to actually synchronize both together. And the reason being is you have different travels between, say, the elevator. You might find the elevator only has to move a little bit. However, the flaps have to move a lot further. So the elevators will actually reach their final resting position before the flaps do. And realistically, when you're deploying flaps and elevator together as a trim function, like you want to trim it with the elevator, you really want the elevators to reach their final resting spot at the same time the flaps reach their final resting spot. And you can't really easily do it this way. So that's why I'm not a huge fan of doing it this way, although some people do use this particular method. It could be handy, for instance, if you've got an aircraft that doesn't need, any elevator compensation, and you just want to slow down the flaps. There's an easy way of doing it, and that's just by changing this value. However, in this example, we're going to cancel this out. So we're just going to go, we're just going to reduce this value back to 0. So again, just full operating speed. Easy as. Alright, let's go back to our main function menu. Now we're going to pull another little stunt here which might seem anti-intuitive. And that's what we're going to do is we're going to remove this switch from the flaps. So at the moment we've got a switch operating the flaps, but we're going to delete that. So what we're going to replace it with is a fixed endpoint value. And you do this on the PowerBox transmitters by using this parameter here, fixed value. Let's try it. So let's see what happens if I select, there's a couple of options, there's on, off, and the dash. Now people get confused with this function. It's fairly simple really when you think about it. So when you have the dashes selected like that, what will happen is the servos will move to their normal 0% travel. In other words, their mid-travel. So it's a locked-in setting. So if I hit OK, these should move to their mid position, which is about roughly 45 degrees or so. If I hit on OK, probably a bit over 45 degrees. So notice I've got a dash in there under flaps for the control. And that's it. They're locked in that position at this point in time, and they won't go anywhere No matter, if I flick a switch or whatever, they're just going to sit there until we add another function to it later, or modify this particular function, and I'll show you how to do that. However, I don't want them there. I actually want them at the 0 degree position. So if I go into here again, if I select off, you'll notice they'll travel to one side of their travel. And this particular setup, they'll actually move to their fully deployed position. There you go. So that's as if we're driving their servos to their one of the endpoints. So we don't want that endpoint, we want the opposite endpoint, because I want them at 0 degrees. So we select on. There you go. So this particular feature, this fixed value, that's all it does. It drives the servo to either one of the endpoints or the middle point. And it's handy for situations like this where I want the servos to start at the endpoint or one of the endpoints. And in this particular case, I need to set it to on. Hopefully that explains this particular parameter. Okay, let's move on. So at the moment, we've got the flaps set in the 0 degree position. There's no control for the flaps. They're just stuck there. They're not going to move anywhere until we modify their curve function. Now if we go into the curves, let's have a look what we can do. So we can modify this line, and at the moment if you look carefully there's a blue line all the way across on my right hand side of the screen. Might be a bit hard to pick up on the video, but there's a blue line there. So that's indicating where the cursor is at the moment. It's on the far right hand side of the screen. And you'll notice the travel across the center line is set to plus 100%. So the servo at the moment is actually in this top right hand corner of the graph, right at the top here. It's moved to positive 100% travel, which is indicated with the horizontal markings on both servo arms. So if we reduce the rate here, watch what happens. If I just click on it, let's drop the rate. You notice I can actually reduce how far the servo travels. So if I go to 0%, it will actually bring the servo back to its mid position. So we've gone from one endpoint to the middle position of the servo, and I can actually go below that. So basically I can set the flaps to wherever I want in their entire servo travel range. So we're going to use this technique to actually set the flaps to where we want them, say for our mid position, our full deployment position, and of course our 0 degree position, which is there. Now how are we going to switch it? So it's all very well to set it here, but we need to be able to switch it somehow. So we're going to use flight modes for this, and the flight modes will achieve two things. One, it'll allow us to modify this rate, and that's simply done by going to here and selecting single. So basically this allows us to now use individual flight modes to switch this option here basically. So with individual flight modes, as the flight modes change, we can set up different rates, we can set up different curves. It's quite a powerful screen here. You can do all sorts of things. Like I said, you can change the curve shape. We're not worried about the curve shape in this case. We can even, if I just get rid of the OK here, we can change the runtime, etc, etc. So our flight modes will allow us to change the rate. In other words, it allows us to change the position of the flaps. Now the second advantage of using the flight modes is we're going to use the fade-in delay of the flight mode to basically control the speed of the function. And you'll see what advantage that has later. Oh, and the third advantage, I just thought of it, is our elevator. So we've got our elevators here. So we've got full up elevator, full down elevator. Now you might deploy the flaps and you need some down elevator trim. So let's put in some down elevator trim. By using flight modes, we can have individual trim settings for the various flight modes. So you can have a trim setting for 0 flaps. We'll have a separate trim setting for mid flaps and another trim setting for our full flap position. And again, it'll rely on the fade-in delay to incorporate this trim. So in other words, if we're set on a fade-in delay of 2 seconds, and this might have to move say 1 centimeter, but this has to travel 3 centimeters. This will travel 1 centimeter in 2 seconds, mimicking or basically matching that fade-in delay. However, this will move its, what did I say, 3 centimeters? This will move 3 centimeters in that same time frame. So both of these, the elevator and the flaps, will reach their end position at exactly the same point in time, which is important. Okay, so let's go into our flight modes. Let's select the flight mode menu. Now I'm going to do another video on flight modes at some later stage because it can be easy and it can also get a little bit more convoluted when you get into this tree setup here as far as selecting the flight modes. There's quite a few options in here, but I'm going to start with the straight linear section of the flight mode tree, or the whole flight mode feature, and we'll just set up, I can leave the standard one to mimic our normal takeoff, say flight mode, and I'll just put in 2 extra flight modes I should say. Let's put in a, say, flap 1, flap position 1 and a flap 2. So let's make a switch, our flight mode switch. So I'll select this switch only because it's long and easy to get to. So all we need to do is basically move the switch. And of course, you can select virtual switches, a telemetry value to trigger a flight mode, or you can have a fixed value as well. But we're just going to use a switch. So I'll use the center position of this switch for our flap position 1. So we can just, I don't know, we'll just call this flap 1. Just go delete, shift, F, L, A, P, space 1. Okay. And here's our fade-in time. So basically this allows us to select a time frame for when we go into flap 1 flight mode. We can tell it how long to delay the servos. So let's pick, say, an arbitrary value of 3 seconds, just so it looks okay in this particular video. 3 seconds is quite long. You might not want to use 3 seconds in actual real life. Now this is important here. So while we want to delay the flaps when we select our flap position 1 and our elevator, we don't really want to deploy any other delay any other servos such as our throttle or ailerons. We still want our ailerons to function at normal speed while we're switching into, say, our flap position 1. So here we just basically enter the servos that we don't want to be included in that delay. So we'll select, say, ailerons. We want the flaps and elevator, so I don't really want those selected. We don't want the throttle, we don't want the rudder, and if you had any other functions you could throw them in there as well. So there you go, ailerons, throttle and rudder will not have a fade-in delay. They'll just work at their normal speed. So you'll flick your flight mode and they'll just keep functioning normally. However, the flap 1 flight mode will delay the elevator and flaps. Now, watch what happens. So if I go out of the, I'll just hit OK, no problems. Okay, so we're in standard flight mode. And I'll just zero out the trim at the moment because I'll show you that later. So we're in the flight mode screen. If I flick the switch now, you'll notice the flap 1 flight mode will be selected, but nothing will happen at this point in time. So notice flap 1 is highlighted, so that's functioning okay as far as a flight mode perspective is concerned. However, you'll notice the servo is not doing anything, and that's because we need to adjust the curve in the function menu. So let's go back into the function menu for our flaps. So here we go, flaps. Let's go into the curve setting for this function, in other words the flap function. And you'll notice I'll flick the switch, our flight mode's changing up the top here, but our curve isn't because we haven't set a different rate for the flap 1 position. Hopefully it makes sense so far. So let's select flap 1 because we don't want to change, we want 0 degree flap, which is what we've already got in the standard flight position or our normal flying around position. But we want to select, say, our flap 1 position, our takeoff flaps. We want to deploy some flap here. So let's play around with this value. So if I go negative, let's put in, I don't know, about halfway on here. Make it a bit more, just to show the servo movement. Click on OK. So in the flap 1 position we have 40%. However, in the standard flight position we have 0%. You also notice the servos move really quickly, and I'll explain that in a second. However, let's see what happens when we now activate or deploy the flaps. Now remember, we set that 3-second delay in the fade in function. So what's happening here is, as soon as I select the flight mode, it's going to take 3 seconds for the servos to reach their final position. Too easy. That looks good. Alright, now the only other thing we have to do is fix up the delay going back. So sometimes you want a delay going back, sometimes you may not want it, or you want a different delay. We can set a delay. That's easy enough to do. So remember, we're going out of flap 1 back into our standard flight mode. So all we need to do is adjust the fade in for our standard flight mode. So we go back into our flight mode screen, and here's our standard flight mode, and you'll notice there's 0-second fade in delay. So let's put in, make it the same, let's make it 3 seconds. Now we also want to adjust the no fade in for certain servos, like we mentioned before. Say for instance our ailerons, throttle, we don't want the throttle delayed, we don't want our rudder delayed. Put them in there. Okay, and you'll notice now we'll have a delay going backwards as well. So we've got 3 seconds that way, and we've also got a total of 3 seconds going the other way. And obviously you can, adjust those times to suit. Now while we're here, I'm going to do the same thing, but I'm going to make a second flap position. So we'll use the same switch. So we'll use switch E. There you go. And I'll set that to on in the fully forward position, or backwards, depending on which side of the fence you're standing. Let's call this flap 2. So this might be our landing flap position, which is maximum flaps. And you'll notice it's already got the fade in functions there, so we'll leave that as it is, or non-fade in functions. So if you look on the screen here, I can flick between the two. Now watch what happens when the servos, when I flick to flap 2 position. Notice they've gone back to 0, and you think, oh, what's going on here? Remember, we have to go back into the function curve for the flaps and adjust the curve, because the curve is set a new curve for flap 2, and the new default curve is a straight line going up to minus 100 to plus 100%. So let's go back into our functions. So for our flaps, we'll go back into the curves, and we're on single. So at the moment, we've got a curve that's got a reduced rate in the flap 1 position of 40%. We've got a curve in the normal or standard flight mode with 100% rate. So let's go to our second flap position and change it from the default 100. We're going to reduce that to full flap position. So let's go, I don't know, let's go to full 90-degree flap, which should be minus 100, because that's the full travel that I've set on this test jig. And let's try it now. Now, the thing, if you look carefully, is when I go to the first position, it takes 3 seconds. Not sure how accurate the timing is, but it should take about 3 seconds. Now let's do the same thing, but now I'm going to switch the switch straight into the flap 2 position. So the servos now have to travel further, but they'll still only take 3 seconds. So the servos will actually start moving faster now to get to the increased travel in the same time frame. You notice the servos are traveling a bit faster. I'll go back to 0. Whereas when I go to the first flap position, they're traveling slower, because the time frame in the fade in function pertains to the end stop. So basically, wherever you set the end stop, that time is the time taken to hit the end stop. And that's the main difference between using the fade in function versus the servo delay. Okay, so we've done the flaps. They're automatically deployed. We hit our flight mode switch. No problems. Now we want to incorporate our elevator trim. Now the elevator trim is really simple. Because we've used flight modes, if we basically look at the elevators, we're using the trim A switch, which is this one here. I use reverse trim, so even though my elevator's over here and ailerons, this is my aileron trim and that's my elevator trim. It's only easy for when I'm trimming out an aircraft, my fingers are busy on this stick, I've got my left thumb mucking around with the trim switches over here to trim out the aircraft. Okay, so elevator trim, if we go into there, actually I've already set it to single, I think the default is global. So global means the one trim setting will apply to all the flight modes. So you've got to make sure you just set this to single as it was. So now what will happen is if I go to the home screen, let's have a look at the trim indicator. So what I might do is I'll put in full, let's put in full down elevator trim. I might go half. Let's go half. Actually, before I do that, I better deploy the flaps. So I'll go back to 0. So you take off, you fly the aircraft, and you might need a little bit of trim for flying around. However, then we deploy the flaps on your first maiden flight. You might want to check out your trim for your aircraft. You deploy the flaps to the first position. And say, okay, that's no problems. But now we need some elevator trim. So basically we can feed in some down elevator. So let's put in a little bit. So I'll put in about roughly half. And you'll notice if I go back to 0, you'll notice they're synchronized to the flaps as far as the timing of the deployment is concerned. So even though the elevator servos have to travel a little bit less than the flap servos, they both reach their end stops at exactly the same point in time. And that's the advantage of this method. Pretty cool. Alright, so let's go to our third switch position, which is our flap landing position. And now we find we've got a maximum flaps, and now we need, say, more elevator trim. So I might just go to maximum. And you'll notice now, if I go back to our first flap position, the elevator servos will go to their trim position that I set for the first flap position. And again, back to 0 degrees flap, we've got 0 elevator trim, or you might have just a smidgen of trim. We'll go to flap position 1. Flap position 2, and the important thing to note here is both of these servos, even though the travelling distance is different between the two, they both reach their end stops at exactly the same point in time. It's important to remember that. Simple as that. Now, I know some of you guys like to have flaps on your slider, because you might want to trim the flaps or basically adjust for wind conditions on the day, or if you're bringing in a big jet, you might not want exactly, say, 50% flaps every day that you fly. You might want 60% or 45% or whatever. You might want to trim it on approach. So you can actually do that pretty easily. I'll show you how to do that as well. So you can still use a switch to basically deploy a particular flap or an approximate flap position, and then you can use a slider or one of the rotary encoders to actually fine-tune the flap position. And basically it's not hard, and I think most of you might have seen this feature before. We introduce a new function, and we might call it, say, I don't know, flap trim. So basically it's going to be a trimmer for the flap function. And we're going to set the slider to control that. So we set slider A, the left-hand slider. And we're going to apply it to the flap servos. So we've got servos 3 and 4 as used in the flap function. So in this new function we're going to use 3 and 4, which is basically flap left, and our flap right servos, because I've relabeled all the servos, so it's not coming up as 3 and 4 but the actual name that I've renamed it to. And you'll notice the default screen shows the default travel and sub trim or center that I've set earlier for the servos. And it was only to align the horns and that. So you notice I've got a slight adjustment of -13 and then +17 on the other servo. And I've reduced their travels to plus or minus 50% for this test jig. No major drama here. So at the moment, if I move the slider, it's actually going to adjust the flaps, the full throw that it's currently set to. However, because the core's got this unique ability with the functions, we can reduce the travel here for the slider. So even though we're going to reduce it here on servo 3 and 4, remember this is only for the slider, not for the normal flap deployment. So let's reduce the travel. Let's go to, say, I don't know, oops, wrong way. Let's go to, say, 20%. So if I go into all these boxes and reduce it to 20%, the slider now will only work over a 20% plus or minus 20% threshold. So that's slider fully one way, and that's fully the other way. It's a little bit exaggerated here. You might want less than 20% depending on your aircraft setup, and that's fine. You think, okay, that's cool. However, if we go back to 0 flaps, you'll notice that the slider still controls the flaps. Now you might not want to do that obviously at 0 degrees. It's aligned with your aircraft wing. You don't want the slider doing anything at that point in time. You really only want it to control or fine-tune the flaps when they're deployed. So how do we do that? Well, again, very, very simple. You go into the flap trim curves. So we select the curves for the trim function for the flaps. You've got to make sure we set the flight mode to single again. So now we're going to have a different curve for every single flight mode. So as we flick the flight mode switch, we're going to have a different curve. So we'll leave the curve on 100% for the flap 1 deployment. So flap 1 deployment means we have 100% throw, or sorry, 100% of the plus or minus 20% servo travel on the slider. So this remains as plus or minus 20% adjustment. So that's probably enough for fine tuning our flaps at mid position. However, if I flick the switch back to 0 flaps, we don't want any rate. So basically, let's kill the rate here. So we're just going to make it 0. Just go down to 0. Okay, so let's see what happens now when I move the slider. Oh look, nothing. We've got no control. Now, you can be sneaky as well. So for instance, if you wanted control, say, below 0, you can actually adjust the curve by going into the curve editor and having like a dogleg curve. There's probably no point showing it, but yeah, you can adjust the curve. So basically, on one side of the slider, you'll have basically no throw in the positive direction. Your throw will basically start from there and go down. So the slider will basically only control from 0 degrees downwards rather than going up the wrong way. Okay, so again, no throw. And we deploy the flaps, and you might want to fine tune them slightly, and you can also fine tune it as they're being deployed, obviously. And you'll notice they're going the wrong way, but I'll fix that in a second. I forgot to do that, didn't I? So I just picked up on that, my bad. So they're going the wrong way. So basically, if I move the slider down, you'll notice the left hand flap servo is going down, but the other one's going up. It's pretty easy, simple fix. If we go back into our flap trim, we go into the servos. Now remember, this servo screen here pertains to only the slider controls. So basically, we're going to reverse the servo. We're going to reverse the, say, the right-hand servo. So flat right, or right-hand side. At the moment, it's set to normal. If we go reverse, now we've got it working in the correct direction. I forgot to pick up on that. Like I said, my error. But there you go. Easy enough to adjust. Now, obviously, we can go back into the curves again for the rates and for the flap trim in the last position, so our flap landing position, we can set a separate curve for that as well. So Again, at the moment, you'll notice it'll overdrive the servos, so go past the 90-degree point slightly. So we've got plus or minus 20%. So yeah, you can basically set, say, just negative 20%, for instance, by having a curve that basically starts from over here and goes over there, rather than going from down here up. So basically, you only operate in that curve region on the right-hand side of the screen, if that makes sense, rather than from there. Cool. Okay. What else can I show you? That's probably about it that I can think of. If you want, I might just show you that curve feature that I was just talking about, because some people might not have that clear in their head. So let's leave the rate to 100% still. So we can go into the curve editor. So at the moment, I'll just do a simple 3-point curve. So I've got 3 points. There's one in the center, one on the left-hand side, and one on the right. So at the moment, if I move the slider, if you look carefully at the blue cursor, you notice as we go below the horizontal line, we're actually overdriving the servo the wrong way. So that say your physical stop is there, you don't want to go, you don't want any more flap travel in that direction. Well, all we need to do is basically draw a diagonal, but instead of going all the way down there, we go from here down to here, because the horizontal line is basically our end stop. So all you need to do is basically edit the points on the curve. So we can bring this bottom one up, say to the horizontal line. So when we have the slider now all the way here, it's not doing anything, but we'll fix that in a second. So basically the bottom of the slider is not going to go below the center line. And then all we need to do is bring up the center point. We'll bring that up to 50% to have a straight line. Obviously you can put in like all sorts of weird functions if you want expo, you can put in multiple points, etc. So let's click on OK. So now the slider will only operate, that's the bottom, that's maximum travel on the slider. So we can reduce the flap travel at the bottom point, if that makes sense. Simple as that. Well, hopefully you enjoyed this video and hopefully you picked up a few handy tips. Like I said, this is only one way of doing flaps. You might have your own preferred method. I know pilots can be picky, but I just thought I'd show you one easy way of doing it. And while we're talking about flap trim, one other thing to be aware of is you can also do the same for your elevator. So we can add another function called, say, elevator trim, and we follow the exact same steps for flap trim, except obviously we're going to assign it to the 2 elevator servos. But however, we use the same slider. So as we move this slider, we not only adjust the flap servos, we can add like an override for the elevator trim as well. So you can feed in like a reduced rate for the elevator, like a fine-tune rate. So as we adjust the flaps, we can compensate for the elevator automatically as well. So that's really handy, especially some of the jet guys really like using a slider on approach because they want to vary the flaps to counteract the conditions on the day. So that'd be a handy option for them. Anyway, I hope everyone found this video helpful, and whether you use this my method or not, it's up to you. But yeah, I hope you found it useful and picked up some good programming tips. Thanks for watching. See you all next time.